Good evening, children.
Good evening, ma'am.
Good evening. Good evening, children.
Good evening,
ma'am.
Good evening. Children, just let me know the last question which we did. Please read the last question from Circles. I'm not sure.
PT equal to 3.8 centimeter. Ma'am, if PT equal to 3.8 centimeter, find QR.
Oh, very good. Thank you. Thank you. Thank you. Yeah. All right. So I'm in the right slide. Fine, children. This is the next question. Please write down this question. From the figure, you need to find angle PAB and the length of the line segment AB. Please write the question and draw the figure. Done, children?
AB is equal to 5√3 centimeter.
5√3, yeah?
Yes, ma'am.
Okay, let's see. Okay, Shakti, let's see. So what do we understand from the figure, children? P is the external point. P is the point lying outside the circle. PA and PB are tangents from this external point P to the circle. So PA is equal to PB, correct?
Yes, ma'am.
Yeah. P is an external point to the circle. PA and PB are tangents from this external point P to the circle. And we know that tangents from an external point of the circle are equal in length. So PA is equal to PB. PA is equal to PB. So PA is equal to PB. Okay. Now the question is to find the measure of angle PAB. Angle PAB, this angle. We need to find the measure of this angle. So now since PA is equal to PB, what kind of triangle is triangle PAB?
Isosceles triangle.
It's an
Isosceles
triangle. It's an isosceles triangle. So which means the base angles are equal. Okay, so these two angles are equal. This angle is equal to this angle, right?
Yes, ma'am.
Yeah. What
Yes,
is the
ma'am.
measure? What will be the measure of each of these angles?
60 degree. 60 degree.
Yeah. Now
60
what
degree,
kind
ma'am.
of triangle is PAB?
Equilateral triangle.
Equilateral
Triangle. So when we started off, it was an isosceles triangle because at that point we only knew that PA is equal to PB, so we named the triangle an isosceles triangle. But when we find the remaining angles of the triangle, each of them is equal to 60 degrees, which means all the angles of the triangle is equal to 60 degrees, which makes PAB an equilateral triangle. And what is the property in an equilateral triangle? All sides
are equal.
All sides are equal. So what's the length of AB?
5, ma'am.
5 centimeters.
So the length of AB is 5 centimeters. So what shouldn't be mistaken is angle PAB is equal to 90 degrees. Suddenly, you know, that might occur to us. Angle PAB is equal to 90 degrees. PAB is not 90 because AB is not the radius. AB is not the diameter. AB is only a chord. And the angle between a chord and a tangent can be anything. The measure of the angle between a chord and a tangent can be any value. Angle PAB can be anything. Angle PAB should not be mistaken for 90 degrees. And maybe we then think of using trigonometry. Because it's see, supposing we thought PAB is 90, then we take it to be a right triangle, and to find AB, we might have used trigonometric ratios. That's incorrect. That's incorrect. So let's see the answer again. So we said PA is equal to PB. Tangents from an external point of the circle are equal. So PAB is an isosceles triangle, which means angle PAB is equal to angle PBA. These two angles are equal. And by angle sum property, the sum of these two angles is 120 degrees because 180 minus 60 is 120. So these two angles, the sum of these two angles is 120. So which makes each of the 60 degrees because they're equal. Now it's an equilateral triangle. The measure of angle PAB is 60 degrees, PAB is 60 degrees, and the length of AB is 5 centimeters because all sides are equal. Please write down, children. Please write down the answer. Done, children?
Yes, ma'am.
Yes, ma'am.
All right. All right, children. Anybody still writing? Please let me know. All right, go to the second one. See the figure. So you can see 3 circles touching. You can see 3 touching circles. They don't intersect. So it's given that AB, the length of the line segment AB is 5 centimeters, BC is 7 centimeters, and CA is 6 centimeters. And children, A, B, C are the centers of the 3 circles. A, B, and C are the centers of the 3 circles. A, B, and C are the centers of the 3 circles. Okay, AB is 5, BC is 7, CA is 6. We need to find the radius of the circle with center A. That is its smallest circle. Okay, we need to find the radius of the circle with center A. Do we find any tangents here? Do we
Yes,
find
ma'am.
any? Name the tangents.
Ma'am, AR, AP.
AR is a tangent, is it? AR and AP are.
Yes, ma'am.
Please look at the diagram.
Yeah.
Watch out very clearly. The tangent cannot cross the circle. It cannot get into the circle, right? It lies outside the circle. AR and AP are tangents.
Ma'am, no, ma'am, no, ma'am.
No.
So children, there are no tangents. No circle has a tangent or a pair of tangents from an external point. There are no tangents here to any circle. So that's what that's why I asked you that question. We should not consider A as the external point and think that AR is equal to AP tangents from the external point A. BP is equal to BQ tangents from external point B. No, they are not tangents. Okay, then how do we do this? So first understand that there are no tangents here in this figure. Now I told you A is the center of the circle. So AR is equal to AP, radius of the same circle. Similarly, B is the center of the circle. BP is equal to BQ, radius. CR is equal to CQ. C is the center. CR is equal to CQ, radius of the same circle. Now what is given? What is given? We are given that AB is equal to 5 centimeters. Now write AB using XYZ. What is AB using XYZ?
X plus Y.
X plus Y. X plus Y is equal to 5. Take up the next one. BC is equal to 7. Tell me BC in terms of XYZ.
Y plus Z equals 7.
Y plus Z is equal to 7. Okay. And then CA is equal to 6. So CA is
X plus Z.
X plus Z
Z is equal to 6. Now add all the 3 equations, children. What do you get on adding the 3 equations? What do you get on adding the 3 equations? X plus Y. Okay, let me write it one below the other. X plus Y is equal to 5. Y plus Z is equal to 7. X plus Z is equal to 6. What do you get on adding? X and X is what?
2x, ma'am.
2x. X and X is 2x. What's Y and Y? I'm not cancelling.
2y.
Y.
Children, I'm not cancelling children. I'm just pointing to the, I'm just slashing it just to show you the positions. Z and Z, 2Z is equal to
18, ma'am.
18. Can I take out 2 common?
Yes, ma'am.
So X plus Y plus Z is equal to 18. So what's the value of X plus Y plus Z?
9, ma'am.
9.
9. 9. We need to find the radius of the circle with center A. So we need to find X or Y or Z. We need to find the radius of the circle with center A. So do we need to find X or Y or Z?
X.
X.
X, we need to find the value of X. Or we need to find the value of X. Then what's the value of Y plus Z? See here, what's the value of Y plus Z? 7.
7, ma'am.
So X plus 7 is equal to 9. Is this right?
Yes.
Yes, ma'am.
X to 2. See, like this, you can find all the values. So now that you got X is 2, now this, we have answered the question. The radius of the circle with center A is 2 centimeters. It's over. The answer ends here. But supposing we had to find the radius of the other circles also. So now X is 2. If X is 2, what do you get from using this one? 2 plus Y is equal to 5, correct? 2 plus Y is equal to 5. So you will get Y is equal to 3. Y is equal to 3. And here, 2 plus Z is equal to 6. 2 plus Z is equal to 6. So Z is equal to Like this, you can find the values of x, y, and z, or the radii of the three circles. There are no tangents here. Yes, children, please write down. So here I have taken CR, CQ as X. That's okay. Anything can be X, Y, Z. See, children, here we found the value of Y because here I've taken APAR to be Y, APAR to be Y. So we have to find here, when I explained, we have to find X because we have taken the radii of the circle with center A as X. Don't get confused. In this answer, X, Y, and Z are marked differently. So here we have to find Y, not X. Is it over, children? I'm not hurrying you. I'm not just keeping a track of the time. I'm just randomly asking you if you finished. You can tell me if you need more time.
Doing now.
Okay, yeah, please.
Yes, ma'am.
Okay. Let me wait for some more time. Somebody's working.
Completed, ma'am.
Completed.
All right, children. Yes. You sure you understood? All of us?
Yes, ma'am.
Yes, ma'am.
Okay. So here we say AR is equal to AP, BP is equal to BQ, and CR is equal to CQ, radii of the same circle. And then we call them X, Y, and Z. We call them, just a minute, children. Yeah, children. So assume X, Y, and Z, and then we are given A, B, BC, and AC. Write them in terms of X, Y, and Z. So you get three equations like this. Add the three equations. You will get another equation, X plus Y plus Z is equal to 9. Now substituting, you can substitute these values. You can substitute these values in this equation to find the values of X, Y, and Z. This is the next one. Children, I'll show you I'll just get back in a minute. Please write on this, I'll explain. I'll just get back and explain, children. Please draw the figure and take down the solution. Give me a minute, I'll get back and explain this. All right, children, we need to understand how we get the result. I'll explain the first result. I'll explain the first one. Am I audible, children?
Yes, ma'am.
Yeah.
Yes, ma'am.
All right, children. Consider a right triangle, and it's in circle, and it's in circle, and it's in circle. Okay. So now the radius of the incircle is r units. The radius of the incircle is r units. So this is also radius r units. Now you can see that the three sides of the triangle, are tangential to the circle. ABC is a right triangle. This is 90 degrees. ABC is a right triangle, and you can see it's in circle. You can see it's in circle of radius r. The three sides AB, BC, and CA of the triangle ABC are tangential. They act as tangents to the circle. They act as tangents to the circle. Now, the first thing we're going to do is we're going to prove that this quadrilateral is a square. How do we do this? We have done a similar one earlier. Now this corner is 90 degrees because it's a right triangle. This one is 90 degrees because
Radius is perpendicular to tangent.
Radius is perpendicular to tangent.
Perfect. Why is this 90?
And radius is perpendicular to tangent.
Very good. So what will be the measure of this angle?
90 degree.
Okay.
90 degrees.
Yeah, in a quadrilateral, when every corner is a right angle, what is it? It can be a rectangle or a square.
Square or rectangle?
Can be a rectangle or a square, but you cannot say it's a square. You can say it's a square only when all sides are equal. So rectangle square, you should not take, when every corner is 90 degrees, it can be a rectangle, it can be a square. But you must say it's a rectangle and prove that it's a square. You must prove that in this rectangle, all the sides are equal, so it's a square. So now this quadrilateral is a rectangle. And I've told you that in a rectangle, when one pair of adjacent sides is equal, it's a square. So in the rectangle, adjacent side, this one and this one, they're equal radius. So the quadrilateral is a square. Is it understood, children?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
This is 90 degrees, radius perpendicular to tangent. This is 90 because radius perpendicular to tangent. This is 90, same reason, radius and tangent perpendicular to each other. This is 90 because it's a right triangle, it's given to us. So this fourth angle also will be 90 degrees. And in this, so now this quadrilateral is a rectangle. And the rectangle adjacent sides, these two sides, adjacent sides are equal to R. They're equal. Or you can say these two adjacent sides are equal because they're tangents from an external point to the circle. They're tangents from an external point of the circle. So you can say this one is equal to this one also. Adjacent sides are equal. So the quadrilateral is a square. So that means this is R, this is R, this is also R, this is also R. Now we know that, okay, I don't know if we know it, but let's just understand this. In a right triangle, this is how we call the legs. The legs are called A and B in a right triangle. The hypotenuse is called the hypotenuse is represented by the letter C. In general, the legs are called A and B. Any leg can be A. One leg is A, the other one is B. The hypotenuse is C. Draw this. I think you finished that answer. Please, you can just give the heading derivation of the result. derivation of the result a plus derivation of the result r is equal to a plus b minus c by 2. Derivation of the result r is equal to a plus b minus c by 2. And take down this diagram and mark off all this. Write in your own words. We have done a similar one earlier. You should first prove that the rectangle is that the quadrilateral is a rectangle, and then prove that it's a square. Okay. So what will be the length of this portion, children? How much is this one?
24 centimeters, ma'am.
4 minus 1.
No.
24 minus 1.
No. This has got no relevance with the question earlier. We are deriving this. We are deriving the result. Don't take the values there. Yes, children.
Can you
A
repeat?
minus R.
You want me to repeat the question?
Yes.
A
Yeah.
minus R. ma'am.
Yeah, who's that?
Srinivasan.
Very good, Srinivasan. Yes, A minus R. The length of this piece will be A minus R. Now somebody else answer. What will be the length of this portion?
B minus R.
B minus R. Yeah. Now if this is A minus R and this is, if this is A minus R, what is this one?
A minus R.
A minus R. What's the reason?
Because tangents from external
Tangents are equal. Length of
external points are equal.
Now if this is B minus R, how much is this one?
B minus R.
B minus R.
Now tell me, what is A minus R plus B minus R equal to?
A plus B.
C, ma'am.
Sorry?
C, ma'am.
Very good. A minus R plus B minus R is equal to C, because from here to here it is A minus R, and from here to here it is B minus R. So A minus R plus B minus R will be the length of the hypotenuse, which is C. So we have A plus B minus C is equal to 2R, or R is equal to A plus B minus C by 2. This is how the result is derived. Now these questions are mostly objective in style, so you can just use the result. So see here, we just use the result to find in radius is the question. In radius is A plus B minus C by 2. You don't have to work all this, but if you're asked to derive this result, yes, you have to show all these steps. Now how do you understand A plus B minus C by 2? Sum of the legs minus hypotenuse by 2. Don't remember, okay, you remember as A plus B minus C by 2, but you need to know what A, B and C mean. A and B are the legs. C is the hypotenuse. So it's a sum of the legs minus hypotenuse by 2. In radius is equal to sum of the legs minus hypotenuse by 2. So this is the value of the in radius. Let's do this again. So what are we doing? We take a right triangle. It's in circle. Okay, so let's call this ABC. ABC is the right triangle, so this is 90 degrees. This is the center of the incircle. This is the center of the incircle. Radius, radius. R, R. 90 degrees. This is also 90. Radius perpendicular to tangent. This is also 90. Radius perpendicular to tangent. Angle sum property. This is 90. So this quadrilateral is a rectangle. And in this rectangle, adjacent sides are equal, so it's a square, which makes this also R and this also R. This is the first part. Proving that the quadrilateral there is a rectangle first and then a square. And so all the sides are equal. Outside that R, they're not the radius of the circle. I told you in some earlier. The length of the line segment is equal to the radius of the circle. That length is not, that line segment is not the radius. You all know that. The length of the line segment is equal to the value of the radius. Next, we normally call the legs A and B. So let's mark A here. Let this be A and this be B. And the hypotenuse is called C. This is C. Now, the full thing is A. So this one will be, from here to here it is R. So the rest of it will be A minus R. From here to here it is R, but the whole thing is B. This full thing is A, but this portion is R. So the rest of it will be A minus R. Similarly, BC is B. BC is B. But this portion from here to here is R. So the rest of it will be B minus C. Sorry, B minus R. The whole thing is B minus R. Now by the property, radius, tangents from an extended point of the circle are equal. If this is A minus R, this one is also A minus R. This one is also A minus R. And if this is B minus R, this is also B minus R. This one is also B minus R. Now, we see that A minus R plus B minus R is equal to C. A plus B minus C is equal to 2R. Or 2R is equal to A plus B minus C. R is equal to A plus B minus C by 2. Sum of the legs minus hypotenuse by 2 is the value of the in radius. Now to get the other one, S minus C, to get that one, R is continue. See, we proved the first result, A plus B minus C by 2 in radius. The second one, in radius is equal to S minus C, where S is the semi-perimeter. Where S is the semi-perimeter. So how do we do that? So now A plus B plus C. I'll tell you why. Okay, so we're going to add a C and subtract. When you add something, you should subtract the same thing. See, we know that semi-perimeter is given by the formula A plus B plus C by 2. Semi-perimeter is given by the formula A plus B plus C by 2. So we want to introduce a semi-perimeter here. So we want A plus B. A plus B is already there, but we want a plus C. Okay, let's introduce that. And then when you add C, you should subtract C also. And then this minus C as it is by 2. By 2. We want to introduce a semi-perimeter. S is equal to A plus B plus C by 2. S is equal to A plus B plus C by 2. We want to get that A plus B plus C by 2. So what we do is we have A plus B and by 2. We don't have the plus C. So we'll add C and we'll subtract C. And then this minus C answer is by 2. So now we have R is equal to A plus B plus C. We got A plus B plus C minus 2C by 2. So you R is equal to A plus B plus C by 2 semi-perimeter. So we'll write a 2 for this minus 2C by 2. You should understand this step. So now R is equal to R is equal to A plus B plus C by 2 S minus 2 gets cancelled, S minus C. Or semi-perimeter minus hypotenuse. Semi-perimeter minus hypotenuse. So it is the sum of the in radius in a right triangle. The in radius of a right triangle. Okay, right triangle in circle, in radius. In radius of the in circle of a right triangle is equal to sum of the legs minus hypotenuse by 2 or semi-perimeter minus hypotenuse. Please write down this derivation. Class, use the emoji. Raise your hand. Okay, so Priyadarshini, Srinivasan, Shreya, Tirunesh, Shruti, Sudarshan, Parkavi, Muttuvel, Manasa, Lakshita, Harshita, Balaharish, Priya, Shakti, Aksharam, Hariharan, Shivani, and Nafi. 9 students have not joined the class. Okay. Good. Please make a note of this. Children, I just want a favor. I just want 5 more minutes. Take a screenshot of this answer. Take a screenshot of this one. You can just complete this. Or maybe I can leave you with this. Have you finished this one, children? Have you finished this?
Yes, ma'am.
If you have not finished this, if you have not finished this one, take a screenshot of this one. And please work this. Take a screenshot of this one, children, please. I'm not confusing. I'll leave you with this slide. I'll put this slide on the screen. Take a screenshot of this one, the next one. Please complete these two. I'll just get back. Take a screenshot of this one. Yeah, leave you with this slide. The earlier one, if you have not finished, take a screenshot. This one, if you have not finished, take a screenshot and complete it.
I mean, exam, should we write the derivation every time?
The next sum, which one? Which one?
For third question, ma'am.
Yeah. Okay. If this one, this question number 3, if it is an objective question, this is the answer. That's all. Just work it like this and select the correct option. If it is for 3 or 4 marks, you have to derive and then use the result.
Okay.
Yeah. Yes. Give you this one. Please work this one and the next one. I'll just get back. Thank you so much, children. I hope you're done with both the answers. Waiting for your responses.
Yes, ma'am.
Yes, ma'am.
Completed, ma'am.
Okay, let's understand them. Okay. Any doubts here, children?
No, ma'am.
No, ma'am.
Okay. So now what is the situation here? Right triangle. Situation is right triangle in circle. In circle, the circle which touches all the three sides of the triangle. In circle. We need to find the in radius. We know that in a right triangle, two sides are called legs and the longest side is called the hypotenuse. The in radius is given by sum of the legs a plus b minus hypotenuse minus c by 2. Or it is also given by semi-perimeter minus hypotenuse. Semi-perimeter minus hypotenuse. Where semi-perimeter, we have seen this, we have seen this term semi-perimeter last year in the chapter Heron's formula. Heron's formula to find the area of a triangle, root of s into s minus a into s minus b into s minus c square units. S is the semi-perimeter, a plus b plus c by 2. So we derive this, and this can be modified to s minus c. This one can be modified to s minus c. So if you want to get s, you need to have a plus b plus c by 2 to get s. So we have a and b. We don't have plus c. So we add c. We have a plus b. Or we don't have a plus c. So we add c and we subtract c. And then this minus c as it is by 2. Now this is a plus b plus c minus 2c by 2. Now split this 2 because you want a plus b plus c by 2, right? So a plus b plus c by 2 minus 2c by 2 minus 2c by 2. Now a plus b plus c by 2 semi-perimeter. 2 gets cancelled minus c. So semi-perimeter minus hypotenuse. So here we have to find the hypotenuse, children, using Pythagoras theorem. Root of 24 square plus 7 square, 576 plus 49. Root of 625, which is 25. The length of the hypotenuse, that is the value of c, is 25. It's found using Pythagoras theorem. I've not worked it. See, all that you know. Very, very basic for you now. For 10th standard. In radius is equal to, what is the value of A? 24. What's the value of B? 7. What's the value of C? We don't know. We'll have to find using Pythagoras theorem. And we get 25. Yes or no, children?
Yes, ma'am.
Yeah. The length of the hypotenuse by Pythagoras theorem is 25 centimeter. So A is 20. See, A can be 7 also. A and B 25, 7 interchangeably. But C is the hypotenuse. C is only hypotenuse. 25 by Pythagoras theorem. Or you can also find it using the formula S minus C, semi-perimeter minus C. So we have found the semi-perimeter for that. See, we find the semi-perimeter A plus B plus C by 2, 7 plus 24 plus 25 by 2. (56 by 2, 28). So now S minus C, semi-perimeter is 28 minus hypotenuse 25, 3. Understood, children? Okay. Now here, to find the length of the line segment PQ, the idea is this. We divide the whole, see, the area of the whole triangle PQR is given to us. The area of the whole triangle PQR is given to us. what we do is we'll take the necessary construction. We will do the necessary construction to divide the whole triangle into 3 smaller triangles. We're going to do the necessary construction to divide the whole triangle into 3 smaller triangles. And we'll say that the sum of the areas of these 3 small triangles is equal to the area of the whole triangle. So construction, join OP, join OQ. Oh, sorry. I repeat, we are given the area of the whole triangle PQR. Okay. Now what we're going to do is we're going to divide the whole triangle into 3 smaller triangles by joining OP, OQ, and OR. Now we have 3 triangles, POQ, POR, QOR. Watch out. POQ, POR, QOR. Now the sum of the areas of these 3 small triangles, when you add the areas of these 3 small triangles, it will give you the area of the whole triangle PQR. It will give us the area of the whole triangle PQR. Now to find the area of the triangles, we're going to use the formula half base into height. So you need to know the base and the corresponding altitude. So for the sake of altitudes or for the need of altitudes, we're going to join. This is the point of contact. You can see that the sides of the triangle are tangential to the circle. You can see that the sides of the triangle are tangential to the circle. Mark off the points of contact. These are the points of contact. These are the points of contact. Join the center to the point of contact. Join the center to the point of contact. Why we do this is to get the altitude. See, this is the triangle. This is the triangle. This is the triangle. And this will be the altitude of the triangle. Again, this is the other triangle. This is the other triangle. This is the altitude of that triangle. And this is the third triangle. Its altitude is already known. And how do we say that OT is the altitude on QR? Because radius perpendicular to tangent. Similarly here, radius perpendicular to tangent, radius perpendicular to tangent. So you have the base and corresponding altitude. Okay. Now we are given that OT is 6 centimeters. This radius, this is 6. OT is 6. So that means, children, is the main idea understood? Area of triangle POQ. Yeah. Area of triangle POQ plus area of triangle QOR plus area of triangle POR is equal to 189. Is equal to area of triangle PQR, which is equal to 189. Now for these small triangles, we find the area using the formula half base into height. Okay, so before that, we have OT is 6. OT is 6, so everywhere this radius is 6. Radius is 6. Then QT is 12. This one is 12. So this is also 12. This is also 12. TR is 9. If this is 9, this is also 9. So we don't know this piece and this piece we don't know. So let's call it X. Because you know the tangents from an external point of the circle, they're equal. So in triangle POQ, children, listen carefully. In triangle POQ, which is the base and which is the corresponding altitude?
Ma'am, 12 plus 6 is base.
Very good. X plus 12 is the base and the value of the altitude?
6 centimeters.
6. Very good. Now somebody else tell me, for triangle QOR, what's the value of the base? for triangle QOR, what's the value of the base?
21, ma'am.
How much?
21, ma'am.
21, correct. And what's the altitude?
6, ma'am.
6. Very good. What about the other triangle? Which is the other triangle? The third triangle?
POR
POR. For POR, which is the base?
9 plus 6.
X plus 9 is the base, and altitude?
6 centimeters.
6. Altitude 6. So write all this and equate it to 189. So that's what is here. Then what happens here? You'll have to cancel. 2 1s are 2 3s are. So you get 3 into x plus 12. 2 1s are 2 3s are. 21 into 3 is 63. 2 1s are 2 3s are. 3 into x plus 9 is equal to 189. So this you can solve, children. So solve this and find the value of x. And we have to find PQ. What is PQ? PQ is x plus 12. PQ is x plus 12. So 10.5 plus 12, just 22.5 centimeters.
One doubt.
Sure, yes.
We can take QOT as triangle.
You can take?
I have done in another method and I got the answer.
Yeah. What is it? Just read out your.
I have took the QOT triangle and TOR triangle.
Okay.
And PSO triangle.
PSO.
Yes, ma'am.
Okay.
So and as QOT similar to QRs, I have multiplied 2 into half into base into height. Similarly,
Okay.
I have done to all other triangles.
Congruent. Yeah, they're all congruent. Yes, okay.
I have got the answer.
Correct, yeah. Instead of taking the whole triangle, you have doubled it.
Yes,
and you added everything and equated to 189, right?
yes, ma'am.
Okay, yeah. You're right. Which are the two triangles? Which are the triangles you considered? You said.
QOT.
Okay, so QOT and these triangles are equal.
Yes,
Are congruent. QOT and this one are congruent, right?
Yes, ma'am.
Correct. And then these two are congruent.
Yes, ma'am.
And these two are congruent.
Yes, ma'am.
So you took one each, correct?
Yes, ma'am. And multiply by 2.
Multiplied by 2. Correct. 1 minute. Let me just. So you took like between these two, you took one of these two.
Yes,
Between these two, you took one of them. Between these two, you took one of them.
yes, ma'am.
All right. Yes. And then, yes, you're right. And doubled up and then equated it to 189. That's correct. Class, do we understand? So then once you find the value of x, Shakti, your approach is also correct. So class, we find the value of x and then the question is to find the length of the line segment PQ. PQ is x plus 12. So 10.5 plus 12, 22.5 centimeters. The constructions are first you join OP, OQ, OR to divide the whole. See, I'll tell you the constructions again. First we join this one, OR, and OQ, OP, OQ, and OR to divide the whole triangle into 3 smaller triangles. We join OP, OQ, and OR to divide the whole triangle into 3 smaller triangles. And then when we have 3 small triangles, we're looking for the altitudes on the bases. So if you take PR as the base, you need its altitude. So we join like this. We join SU or OU and OS. OU because it's the altitude for triangle POR, and OS altitude for triangle POQ. And 90 degrees, how do we get radius perpendicular to tangent? Okay. I hope all of us have understood this clearly. Okay. What about this one? Any questions here, children? No questions?
No, ma'am.
Okay. So here we find the area of one triangle and double it to get the area of the quadrilateral. What is it here? O is the center of the circle of radius 5 centimeters. At a distance of 5 centimeters from O, a point P is taken. So see here, what is P? It's at a distance of 5 centimeters from O. And then two tangents PQ and PR are drawn to the circle. Find the area of the quadrilateral PQOR. All right. So OQ is perpendicular to PQ, radius perpendicular to tangent. OR is perpendicular to PR, radius perpendicular to tangent. So using Pythagoras theorem, we find that this is 10 centimeters. And whatever is the area of this triangle, the same will be the area of this triangle, because here also same values, 5 root 5, 5 and 10, same values. Whatever is the area of this triangle, the same will be the area of this triangle. So find the area of one triangle, half base into height, double it to find the area of the quadrilateral. Half base into height. It's not a hypotenuse. You cannot take the hypotenuse. Half base into height other than the hypotenuse. Any questions here, children?
Ma'am.
Yeah.
Ma'am,
Yes.
hypotenuse is longest side, but here pi root 5 is there.
Sorry, hypotenuse is?
Hypotenuse should be the longest side, right, ma'am? But here pi
Correct.
root 5 is.
Root 5 is equal to
Oh,
more
okay,
than 2.
1 minute. What is the, when you square 5 root 5, what do you get?
125 centimeter.
120.
When you square 10, what do you get?
100.
So which is
100.
longer?
5 root 5.
Yeah.
And also root 5
1
is equal
minute.
to
What is the value of root 5, Srinivasan?
I'm not sure.
it's more
Oh,
than 2
that's a good
centimeter.
answer. 2.234. It's more than 2, right?
Yes, ma'am.
So 5 into 2.234 will be more than 10.
Okay, ma'am. Thank you.
The value of root 5, okay, let me show it here. Thank you for that question, Srinivasan. This is what I want. So 5 root 5 is equal to 5 into 2.234. We don't have to find the value. We know 5 into 2.234. 5 into 2 itself is 10. So into 2.234 will be more than 10. That's enough. This is greater than 10. That's enough. Correct,
Okay,
Srinivasan?
thank
Yeah.
Yes, ma'am.
In a circle of radius 5 centimeters, O is the center of the circle of radius 5 centimeters at a distance of 5 root 5 from O. So see here, at a distance of 5 root 5 from O. At a distance of 5 root 5 from O, a point P is taken. A point P is taken. Two tangents PQ and PR. Two tangents PQ and PR are drawn to the circle. Find the area of the quadrilateral PQOR. So we have to join this. Now this distance is given to be, it's given directly at a distance of 5 root 5 centimeters from O. P is taken. So from O, 5 root 5 centimeters P is taken. Everything is given. So and radius is 5 centimeters. So in this triangle, this is a right triangle because radius is perpendicular to the tangent. This is a right triangle. So you can find PQ using Pythagoras theorem. The hypotenuse is 5 root 5, not 5 or anything else. 5 root 5 is hypotenuse. So by Pythagoras theorem, we get this is 10 centimeters. So the area of this triangle POQ, the area of the triangle POQ is half base into height. So 25 centimeters square. The quadrilateral will be 25 plus 25, 50. Is it understood, children?
Yes.
Yes, ma'am.
Okay. Try this one, children. Draw the figure. done?
No, ma'am.
Okay, please take down the figure and find AB and CD.
AB is equal to 16 centimeter.
AB is equal to how much?
16 centimeter.
Okay, what about CD?
And CD also same.
Very good. All of you have taken down the figure?
Yes.
All right. The value of small r is 6, so that means this is 6. Capital R is 10, so OA is 10. So how much is AP? 8. So this PP is also 8. 8 plus 8, 16 is the length of AB. Pythagoras theorem, children. It's a tangent to the inner circle. See, this one is a tangent to the inner circle. This is 90 degrees. So if AB is 16 centimeters, CD is also 16 because last year we have seen a result. Equal chords that are equidistant from the center are equal. If two or more chords are equidistant from the center, then the chords are equal. Just a minute, children. Yeah. So I was telling you that the value of small r is 6. The value of small r is 6. So to mark it in this figure, OP is 6. The value of capital R, that is the radius of the outer circle, is 10. So that means OA is 10. OP is the radius of the inner circle. OA is the radius of the outer circle. So using Pythagoras theorem, because OP is perpendicular to AB, this is the radius, this is the tangent. This one is the tangent to the inner circle. AB is a chord to the outer circle. To the bigger circle, AB is a chord. See, AB has different relations with the two circles. AB is not a tangent to both the circles. To the inner circle, AB is a tangent. To the outer circle, AB is a chord. Inner circle, these are two concentric circles. These are two concentric circles. To the inner circle, AB is a tangent. To the outer circle, AB is a chord. Now we treat AB as a tangent to the inner circle and OP the radius. So radius perpendicular to tangent. That's how we have this 90 degrees. Pythagoras theorem, this is 8 centimeters. 8 plus 8, 16. Okay, again, how is this also 8? Because 9th standard we've studied the perpendicular from the center to a chord bisects the chord. The perpendicular from the center to the chord bisects the chord. Or you can also understand like this, these two triangles are congruent. No, this one and this one will be congruent if you join it. They're congruent. So CP, CTC, AP is equal to BP, 8, 8. The length of AB is 16 centimeters. And again, another theorem. Chords that are equidistant from the center are equal. Chords that are equidistant from the center are equal. So see here, OP is the distance. OP is the perpendicular distance of AB from the center. OQ is the perpendicular distance of CD from the center. OP is equal to OQ. The distances are equal because they're the radii of the same circle. So AB is equal to CD. OP is equal to OQ. Therefore, or this implies AB is equal to CD. OP is equal to OQ. OP is equal to OQ because radii of the same circle, the small circle. So that means the distances are equal. OP is the distance of AB from the center. OQ is the distance of CD from the center. The distances are equal, so the chords are equal in length. So AB is equal to CD. See, there are two theorems or two results. Equal chords are equidistant from the center. If the chords are equal, their distances from the center are equal. Converses, if the distance of the two chords from the center are equal, then the chords are equal. See here, if OP, if the distance, here the distance OP is equal to the distance OQ. So AB is equal to CD. See the answer? Please write down, children. Any questions you can ask me? All based on results which you've seen last year. Any questions, children?
No, ma'am.
Okay. Let me show you those theorems. Yeah, children, you can take a screenshot of this one. Please go through these. We have seen them last year. So you can see theorem 3 and its converse. Theorem 3 and its converse. Equal chords of a circle are equidistant from the center. Chords equidistant from the center of a circle are equal in length. Take a screenshot, children.
Yes, ma'am.
All right. The chord of a circle of radius 10 centimeters subtends a right angle at its center. Find the length of the chord. This is simple.
Root 2.
So circle, chord. This chord subtends. The radius of the circle is 10 centimeters. This chord subtends a right angle at the center. This is a center O. So this chord, if I call it AB, AB subtends a right angle at O. So join A to O, B to O. This angle is 90 degrees. The radius of the circle, see, the radius is given to be 10 centimeters. And it subtends a right angle at the center. We need to find the length of the chord AB. Pythagoras theorem. Pythagoras theorem. It's 10 root 2. It's 10 root 2 centimeters. This is the chord AB. It subtends. This is center. Subtends meaning you should join OA and OB. Should join the ends of the chord to the center. This is 90 degrees. Radius is 10. So the hypotenuse using Pythagoras theorem is root 200 or 10 root 2 centimeters. So the length of the chord is 10 root 2 centimeters by using Pythagoras theorem. Understood, children? Is it understood?
Yes, ma'am.
Very good. Done, children? Finished writing this one?
Yes, ma'am.
Yes, ma'am.
All right, children.
Yes, ma'am.
All right, children. That's it for today's session. Thank you so much. Good night.
Thank you, ma'am.
Thank you, children. Good night.
Thank you, ma'am.
Thank you.
Thank you, ma'am.